Okay. Am I audible? Okay. Dear participants, good afternoon. On behalf of the organizing committee, I welcome you all in the 10th technical session of ATAL Online FDP on Data Sciences. And the resource person for this session is Dr. Rajiv Ratan Shah sir. And now Dr. Muhammad Nadeem will introduce Dr. Rajiv Ratan Shah.
Hello.
Dr. Manish, Dr. Nadeem.
Thank you, Dr. Sajid. Dear participant, good afternoon to all of you. On the behalf of organizing committee, I welcome you all in the 10th technical session of ATAL Online FDP on Data Sciences. The resource person for this session is Rajiv Ratan Shah, sir. Dr. Rajiv Ratan Shah, currently working as an assistant professor in the Department of Computer Science and Engineering, joint appointment with the Department of Human Centered Design at IIIT Delhi. He received his PhD in computer science from National University of Singapore. Before joining IIIT Delhi, he worked as a research fellow in Living Analytics Research Center at the Singapore Management University, Singapore. Prior to completion his PhD, he received his MTech and MCA degrees in computer applications from Delhi Technological University, Delhi, and Jawaharlal Nehru University, Delhi, respectively. He has received his BSc in Mathematics honors from BHU Banaras Hindu University, Varanasi. Dr. Shah is the recipient of several awards, including the prestigious Heidelberg Laureate Forum and European Research Consortium for Informatics and Mathematics fellowships. He won the Best Student Poster Award in 33rd AAAI Conference on Artificial Intelligence at Hawaii, USA, won the Best Poster and Best Industrial Paper Awards in 5th IEEE Big Conference at Singapore, won the Best Poster Runner-Up Award in 20th IEEE International Symposium on Multimedia Conference at Taichung, Taiwan, and received the Honorable Mention Award at IEEE ICDM Conference at Beijing, China. He has also received the Best Paper Award in IWGS workshop at the ACM SIGSPATIAL Conference 2016 San Francisco, USA, and was runner-up in the Grand Challenge competition at ACM International Conference on Multimedia 2015, Brisbane, Australia. He is involved in organizing and reviewing of many top-tier international conferences and journals. His research interests include multimedia content processing, natural language processing, image processing, speech processing, multimodal computing, data science, and social media computing. We are fortunate to have a session with Dr. Rajiv Ratan Shah, sir. Thank you, sir, and you can start with the lecture.
Thank you so much, Nadeem, and thank you so much, Sajid, and all the organization committee for the invitation. And it is an honor for me to present my work to the very live community at the AMU. So let me share my screen and get started. Okay, wait a second. Yeah. So I hope you can see my screen.
Yes, sir. It's
Okay,
visible.
wonderful. Okay, thank you so much. And again, thanks to all the organization committee. And I'm sure, I mean, this FDP is going on great, and you have already have a lined up great speakers in the event, and I hope all the participants are getting benefited with that. So in the same line, I will try to introduce some of the work we are doing at our lab, and specifically, I will try to focus on how basically the different type of problems can be solved using AI. So here the intent is not going to too much technical details, because I've been informed that the people, many participants are from the different streams. So I will respect that and try to mostly provide an overview of the different works can be solved, because how it can be solved, it's not a big deal. I mean, you can jump into the more technical details and solve. Okay, so let me get started with my talk. So the topic for my today's talk is leveraging multimodal data and AI for social good, because these days everyone is talking about AI, and using AI, I mean, there is a lot of discussion as well. I mean, it may basically harm the people. It is probably losing, people are losing jobs and so on, right? So, I mean, there are several aspect of any kind of two sides of any coin, like good or bad. So as part of this talk, I will try to focus on the I mean how it can benefit people. And definitely, I mean, other parts you need to deal with. I mean, for that, basically, we need regulation, policies, and probably we need probably AI as well to deal with the bad side of the AI. So let me start with my presentation. So it's just a picture of my lab and different students and the research assistant in my lab. So I lead the MIDAS lab in IIIT Delhi. So MIDAS stands for Multimodal Digital Media Analysis Lab. From the name itself, I believe it's clear. So we deal with multimodal data, and the reason being, I want to focus on multimodal data in my lab because uh, in daily life you come across multiple modality of the same thing, and often one modality is not enough. So for example, as a human, we see a number of things, we hear a number of basically we hear the audio, and probably we can write and we can see. So it's kind of, we deal with multiple sensor at the moment. So like human has 5 6 sensors, right? So in a way, I mean, we deal with multiple modalities, and that can help you basically to better interpret the information and probably solve the problem efficiently. So in our lab, I mean, we do have a number of PhD student and masters and research assistant and so on. And so we do not only have the student from IIIT Delhi, but we also have a number of students from other institution as well who are working with us full-time, part-time basis for different ways, like for their BTP project, for BTP, for their BTech thesis, MTech thesis, internship, and so on. So alumnus from our lab are well placed to the good companies like Google, Microsoft, and they also get admitted to the top institution in the world like CMU, Columbia, for their masters and PhD program. So one thing I believe in, collaborating with the, I mean, different people. So that's how we collaborate with the many top people in the world, and we do have a number of research projects going on in collaboration with them. So you can see the people ranges from probably from some people from US, probably Europe, and as well as India and so on. So the theme of our lab is basically, as part of today's talk, I mean, I try to mainly focusing on the education and healthcare, but in our lab, I mean, we try to focus on a number of many other stuff. So probably I can, if the time permits, I can provide some overview of those problems, which basically can provide you a way of thinking like how AI can solve different problems. So so specifically, we are focusing on building NLP and multimedia based system for society. So so feel free to ask me any questions if organizer basically has allowed you to do so. Otherwise, I can take the question by end of the call. So anyways, I mean, in between, probably I need to interact with the attendees. So let's see how we can figure out with that. Okay, so to start with one of the work, I would say the major work that we are doing at our lab is automatic speech recognition. So automatic speech recognition, probably from the name, it might be very complex to you, but in daily life we are using this. I was a bit surprised to know, I mean, when I was just going out, I mean, the person who cannot write also using this ASR system to write the name. So for example, one of the shopkeeper I was interacted with, so he wanted to save some number or so. So since he cannot write in English, he just click the Google ASR, like this number save as say Ramesh or Sahid or Sajid, whatever. So in this case, I mean, using ASR system, the speech can be converted to the text, and in this way you can basically get benefited. It can basically benefit people. So for example, daily life, I mean, many people are using Alexa. So Alexa is nothing but a kind of application of ASR. So where basically whatever the speech that you're saying, that is converted to the text. And once it is converted to text, so for the given query, it can basically find you the answer and fetch it and basically give it to you. So in a way, I mean, the ASR technology is behind that. Similarly, Google Assistant and many other things are there. So the next part we are focusing on, and so you may ask basically what different we are doing. So ASR is already, I mean, the Google and many other companies are already working on. So specifically, we try to focus on the Indian and African accent. The reason being, the Google ASR works very well for the native English speaker, but not for, not for speakers, local Indian speakers like Indian and so on. So that's why, we have started with uh, ASR for Indian accent as well as Indian languages. So right now we are building ASR for Hindi. So if you say something in Hindi, we will write that part in Hindi, so that it can help you with that. Similarly, the next part we are focusing on the visual speech recognition. So in this part, from probably from the name itself, it's clear. So when we say the visual, we try to focus on, or probably we look at the video part of the conversation. So like in this case, when some person said, we don't care about how the person's lip movement is, or probably focus on the face of the person and so on. We only focus on the audio part. So in case of visual speech recognition, we focus on the lip movement, we focus on the facial expression part to understand what person is saying. So uh, so specifically we are working on lip reading and the speech reconstruction based on only on the lip movement, because there might be the case, the person cannot speak, right? The person cannot speak. In that case, only based on the lip movement we can understand what the person has said, and we can also generate the speech what the person has said. Similarly, it can help in many other scenarios. So one example probably I can give, in surveillance. So you can see the CCTV is spread everywhere, right? So but the CCTV don't have the, you can say, the sound whatever the conversation is going on. So if you're looking at some suspect, right, in that case only the CCTV feeds will not help you. If you can generate the whatever the lip movement is there and whatever the conversation they are having, in that case probably that may provide you more detailed information. If you're looking for some evidence or probably some other information, so in this way the lip reading can help you. So there are cases basically in US where expert lip readers are asked to basically look at some videos, and based on that judge has given the punishment and so on. So in this way, the lip reading can not only help in the healthcare, it can help in the, say, surveillance. It can also help in, say, in uh, uh, entertainment. So for example, we all know the first the dumb movie is the Alamara, right? In that case, uh, what about, how about if you want to look at Alam Ara movie today? You probably don't like, right? In that case, if somehow in the entertainment industry, say for example in the cartoon as well, so based on the lip movement, if you can generate the sound in the silent movie, that will basically attract more audience, and probably that will be more interactive for the people who are watching the videos. So these are some of them. Some of the applications. Probably I will go more into the details of this visuals, speech recognition and the reconstruction part in the latter part of my slides. Another work that some of my lab members are doing on the hate speech and the malicious user detection in the code switch scenarios on social media. So for example, these days, all the big companies, social media companies, they try to basically ban or probably try to find the people who are basically using abusive languages on the social media, right? But these companies are often, say, based in US, and they are mostly dealing with the English language. They don't have capability, or probably they don't have bandwidth, or whatever could be the right term. So they cannot deal well with the code switch scenarios. So where basically if you want to abuse someone on social media, so instead of writing in English, probably you can write in code switch language like English, or probably use you want to write some abusive language, though you'll use the English letter, but write that when you read it, it will be uh, read like Hindi or Arabic and so on, right? So in this way, basically these people disguise themselves by using code switch languages. So we need some systems basically which can also detect such people and probably notify the concerned authorities to take action on them. So another work that we are doing these days as part of our lab is mental health problem, because this is one of the biggest problem in Indian society specifically, and we don't acknowledge that. And so that's why we feel that we must focus on social media data and look at if some person is basically facing some mental health issues and so on. So that can help us basically with the suicidal ideation, depression detection, and social media. And there are a lot of cases where basically there is a clear trend and indication that if some person is showing suicidal ideation or depression, basically you can clearly see through their social media handles. So this is one of the work that we are doing. So recently we have a number of publication, even Times of India covered our this particular research work recently. So building multimodal information retrieval and extraction system. So as I said, often if you want to search something or retrieve something, only one modality may not give you the best information or correct information sometime. For example, if I just search the word bank, right? So the bank could be the where people deposit the money, or bank could be the bank of the river, or probably many other things, right? So often if you have more information, so probably you can deal with this ambiguity, right? There are many other examples, and often basically so for example, if you're looking for apple, right? If you just search on Google apple, apple can give you basically the mobile phone, basically referring to the mobile company, or probably the fruit. So if basically you can add more modality or the more contextual information, that basically help you to deal with such problems and give you the better information. So that's how we are currently working with Delhi police on this particular problem. So where basically you give us some facial attribute of the person or suspect, and we can basically find out that person from our database, criminal database that we have. So that is based on the multimodal information. So we are looking for facial attribute, we are looking for probably the location, name, whatever the information you can provide, and we can find the suspect from the database. Similarly, we are focusing on the knowledge graph construction for different domains, because this help you to better search and so on. Automated system for number plate and damage detection, car insurance claim. And because these days, if you see in the days of basically the digitalization, so we try to reduce the manpower wherever it is possible. So for example, in current scenarios, what happens if some accident happens, and in that case the car owner basically file a complaint, some surveyor come to your home, look at the car, how much damage is there, and accordingly basically it issue the claim and so amount and so on. So how about basically we can the surveyor do not need to come, because that also involves a lot of money and time and so on. So in order to expedite the process, in order to basically reduce the unnecessary money, so what you can do, how about just take a picture or the video of the car, damaged car, and our automated system basically can figure out how much damage is there, how much claim should be there. And similarly it should also try to find whether it's a just fake video or something, in a sense, though there is no damage, or probably the car is different and so on. And you need to basically deal with all those cases. So some of the challenges are there. Similarly, we are also currently also focusing on the multimodal sentiment analysis. So for example, uh, some protest is going on, or probably the government has proposed some policy, how people are responding to that, right? So you need to basically look at the different senses, you can see the different information which are available on different platforms, and based on that it should automatically provide generate a report and provide a feedback to the government, or probably the organization, if something is going good or bad or so on, at least the how the people is reacting to that. So ideally the government should listen to the feedback, or probably the responses of the people, and take appropriate action, or probably do the amendment if required. And so another work that we are doing, mitigating the fake news detection, because this is one of the biggest problem we are facing these days. So is there any way we can basically somehow deal with fake news by utilizing multimodal information? And so this is one of the work one of my PhD student is doing in collaboration with TCS. So many of these work basically led us to basically publication at the top conferences like AAAI, one of the best conference for AI, Asia Multimedia, same the conference for multimedia. ICDM is one of the best conference for data mining. Interspeech is the best conference for speech processing and so on. So that also help us to win a number of awards. So I don't want to go in detail. So in terms of skills, tools, and frameworks, we are since we are one of the multimodal lab, so we are focusing on natural language processing, image processing, speech processing, and so on. And one of the benefit of one of the, so as we mentioned, get selected to the Heidelberg Laureate Forum. So this is one of the biggest meet of all the Turing Award winner, as well as you can see here all the Turing Award winner and the Field Award, uh, and basically all the basically the popular awards in the mathematics and computer science. So this every year held in Heidelberg. So many of from your institution can also apply for this. And fortunately, this year this event was online due to, I would say, the grace of COVID, because otherwise it is may not be possible for people to attend this such a event. Yeah, I mean, being at home or so on. So we are, through our AI solution, we are helping different organization by building solution for them. We are working with Delhi Police, Delhi Jal Board, Delhi government, and a number of companies, Bloomberg, and so on. So the motivation is, I believe I'm clear here, because as I mentioned, uh, we deal with in daily life different kind of data. So that is text, image, video, audio, animation, and many other things. So that's why, I mean, the multimedia stands for basically the multi and media, the different forms. And often it deals with it often basically it gives us the too amount of data. So it's a too large and too complex, and sources are real-time uses, social, traditional media, and so on. So that's why multimedia is increasingly becoming the biggest big data. And since we have the huge amount of data, that also come with challenges, but as well as it also help us to solve different problem for the people. So that's how it can help you to basically provide a better solution, efficient and effective solution for education, for healthcare, for e-commerce, banking, and so on. So since this FDP is on data science, so I will briefly discuss what data science is and who are the people who should be called data scientists. And then probably I can go further into the details how these things can be used to solve different problems. So as we know, I mean, the data science is one of the most popular area these days, and it is highly paying job. I would say the data scientist is one of the highly paying job in the current era, right? So the data science, basically this is the Venn diagram of data science. So data science basically include the different popular areas. So one is the computer science, maths and statistics, and the subject matter expertise, because you need to deal with some kind of data. So that's why probably we need the subject. So for example, if you're building something for bank or commerce, e-commerce, then probably we need the e-commerce subject matter information, and computer science and maths are the equally important. So that's why data science deals with basically the computer science, maths, statistics, and the subject matter, that is the domain information. So that's why a data scientist should have some of the learning knowledge. It's more a computer science aspect and the maths and statistics aspect. Understand the multiple analytical functions. Similarly, the ability to work with unstructured data, because in daily life we often encounter the unstructured data, and but computer cannot understand the unstructured data. So that's why we need a way to convert this unstructured data to some structured format, so that the computer basically can deal with those data. Similarly, since all these data need to be stored and queried, so that's why we need some hands-on experience in SQL and database coding. Similarly, I mean, there is no shortcut without programming, so that's why you need to have strong knowledge of Python, R, or whatever the other programming languages are required for your uh, platform you're using. So basically, if you see the computer science and the maths and statistics intersection is often called machine learning. So that is the area we are mostly interested when we are dealing with data science. Similarly, computer science and the domain information, often they build basically the traditional softwares, and maths and statistics and the domain information, so that is the core research or theoretical research often we do. So if you look at this unicorn is the most high paying job for any data scientist. So if you have uh, computer science knowledge, math statistics knowledge, and the domain knowledge, so you will be the, I mean, you will be the leader in data scientist. So I hope this has provided you some overview of the data science and data scientist. So why machine learning? So uh, because I mentioned here in the previous slide, the computer science and the maths statistics, basically we deal with the machine learning. So why we need machine learning? Because no human experts, and as well as so the reason being we use machine learning is primarily concerned with the accuracy and effectiveness of the computer system, because end of the day, using the machine learning we want to solve a problem which also human does and human can do. But the problem is human has a limitation in terms of speed, in terms of cognitive load, and so on, right? That's why people have started building software so that it don't commit the mistakes, because the people can basically get tired and do the mistake which earlier he was not doing too, but machines cannot, right? Similarly, I mean, that is the area reason the machine learning basically can help you with try to achieve the same accuracy or better accuracy often and effectively. When I say the effectively, human probably can also solve the problem with say 90% accuracy, machine can also achieve, but the way or probably the faster a computer can do is probably the human cannot match. So for example, I was giving an example of hate speech detection on social media, right? So on social media, millions billions of such posts are created every minute, every day, and so on, right? So it is not possible for human to look at all possible posts and find out which one is abusive, which one is not, right? In that case, we need some kind of automated way, or we need some kind of software kind of, which can help you to scan all those posts very very quickly and filter out the people who are say abusing or probably the suspect. Similarly, the example of I was giving for suspect finding from the given database. I mean, in this way, I mean, machine learning can help you efficiently finding, looking at the suspect from say 1 million data set, right? So in a way, I mean, machine learning can help you with that. And uh, so in machine learning, basically there are several paradigm. I mean, I will basically quickly discuss about the three popular paradigm. So classification, regression, and clustering. So classification and regression basically come under the domain of supervised learning. So when we say the supervised, it means, I mean, you need to first show example or teach examples to the computer or your machine learning model, and then for a given new data, your model basically will predict or help you to answer the question. So for example, for example, one of the very popular data set is called ImageNet. So ImageNet basically having thousands of classes. So those classes could be human, cat, dog, house, car, and so on, right? So in case of supervised learning, you need to basically first show a good number of examples to the computer, your machine learning model. So for example, in our ImageNet data set, so say I will first show say 10,000 images of different cats, and I will tell the computer, okay, so this is cat. So using this 10,000 examples of cat, the different characteristics of the cat, the machine learning models will learn, right? And so how it works, so basically once the model is trained, whenever you give me a new image of the cat, so that is not the same image that you have seen so far, that might be similar but not the same, I mean. So based on the 10,000 examples the machine learning model has seen, it will try to correlate whatever the features or the characteristics of the cat I have learned, whether it is matching with the new image or not. If it is matches with some threshold, you'll say, okay, so this is a cat picture. Otherwise, you'll say not, or probably you can look for other classes that you have. So it's basically it's an example of supervised learning. So basically, you need to give the first show examples, and after once it learn, it will basically try to give the answer for unseen example. In case of unsupervised learning, you probably don't have the labels, you don't have the ground truth for the data sample data point that you are having. In that case, you need some ways basically cluster them. So that's how group them. So grouping is nothing but the clustering here. So here in this case, I mean, despite you don't like, for example, in case of supervised learning, this particular classes that you have, that is for hate speech, that is for not hate speech. But in this case, I mean, you don't know basically which class is that, but at least I mean, okay, so this is one type of group of data point which are similar, this is one group of data point which are similar, and so on. So in supervised learning, there are two paradigms. So one is the classification. In case of classification, you have a number of classes, and based on a given past experience of data that you have seen, the example of cat I was giving. So whenever you give me a new data, a new image, I will try to classify using the model I have trained, and it will tell, okay, so out of 10,000 classes, so this particular image matches most with say dog, not with the cat or not with the probably other classes. In this way you can say, okay, so this particular image is belong to dog. In case of regression, the major difference here, I mean, here you deal with the real, here basically you deal with the different real number of values. So for example, so instead of saying classes, cat, dog, and so on, I mean, in case of say, suppose you're dealing with how many marks should be given to the student, right? So 1, 2, 5, 10, and so on. Similarly, the clustering I've already mentioned. So here basically try to group the different similar data. So these are three very popular paradigm in the machine learning, and often you mostly deal with this. I mean, there are many other like RL and so on that I'm not going to the detail at the moment. So one of the major question many people have, and many people have that because there is often interchangeably use the same word for the same thing. So they refer AI, machine learning, and deep learning are the same or are they different? So often they get confused with this. So I thought let me throw some light on that. So basically AI is a superset of machine learning. So when I say the superset, basically in AI, it's basically a technique which enables you machines to mimic human behavior. So it try to do exactly what human does. So there are several ways. One is the machine learning. There are some other expert system that you have seen in the past and so on. So machine learning is basically a subset of AI, but a kind of here basically which uses a statistical method to enable machines to improve with experience. So here in this case, it is just a kind of function which try to learn what kind of input you have given and what kind of output you'll get. So this is about machine learning. And in case of deep learning is a subset of machine learning which makes the computation of multi-layer neural network feasible. It's very similar to, you can say, the way human process the different input in the brain through the neurons and pass it to the different layers, and finally the last layer take the decision. So these are the key difference. So this is all about a background of data science, AI, machine learning, and so on. The reason I wanted to cover, so that now whenever I'm going to jumping to the different problem can be solved, it will be clear to you. So any questions so far, or should I continue?
Uh, Ratan sir, there is a question. If in between I can interrupt you.
Yeah, sure.
Uh, this is from Miss Rachna. She is asking that instead of showing thousands of different images of an object for recognition or classification task, why do we need so many training examples? Instead, what if we iterate the model through a few examples multiple times? So I think, sir, the question is a trade-off,
Okay, got
whether
it.
we should have limited example
Sure,
runtime
sure.
many times,
Yeah.
or we
So
should
yeah, so let me answer that. So if I understood the correct question correctly, the reason you need so many example because, I mean, again, firstly, I mean, there are different type of cats, right? Suppose I'm giving this examples of cat. So even though you have the same type of cat, again, I mean, the different same cat, the picture that you're capturing may not be from the same direction. Probably some cat is covering from frontal face, probably some is covering from say some angle, and so on. So machine learning basically models need to understand the different features from different ways actually. So that is the reason, I mean, the more example that you give, the more features it will learn. So that is one of the way, I mean, one of the reason why machine learning or the basically the deep learning are data hungry, because it need to learn all the key points in the given image. So I hope it has answered the question.
Sir, her next consideration is then can we learn the features from the videos of an image rather than going through the images one by one?
Yeah, it is indeed. I mean, that's why, I mean, the because video is nothing but a set of frames, right? Suppose normal video is a 60 frames per second. In that case, yeah, you just give the same frame. I mean the video, and from the video essentially you don't directly deal with the video. I mean, you need to convert that video to different frames it has, and based on that you can you can basically deal. So yeah, it's a kind of same thing, right? It's kind of same thing.
Hello. Yes, sir. There is one question from my side,
Sure.
and that is, I want to get it clarified. When you say multimodal, is it the multimodal that we learn that a function could have many maximas or many minimas, or it is the learning the different aspects of something?
So when I say the multimodal, I'm referring to the different source of information. So for example, right now we are communicating, right? So I'm showing this particular my screen. So that is one modality. So kind of text data that you have. I'm speaking something. So that is the audio that you have. That is another modality. Similarly, I mean, you're looking at my facial expression. I'm saying also saying something. That is another modality. So if you want to add more modality, I mean, that could be probably the location I'm speaking with. So
Yes.
when I say the multiple modalities, I'm referring to the different source of information where you are getting the data for the same thing. So
Oh,
so the
okay.
event is same, but we are getting the different type of data.
Yeah. Okay. Thank you, sir. You can carry on with your lecture, sir.
Okay, sure. So the next part I want to focus on the how the basically the uh, multimodal information can be utilized for education, especially which is heavily suffered in COVID situation. So as we know, I mean, COVID-19 impacted education and the worldwide very significantly. So it lead to losses in learning, increased dropout, and I mean, number of issues are there, right? Because it has also increased in unemployment, because students losing job, the companies are not giving the jobs offer, and so on. So it also basically have a lot of side effect due to health, because and similarly, I mean, because when we are discussing with the students, I mean, they found it very difficult to learn online as compared to the offline classes that we have. So it has a lot of issues and the impacts we have. But again, at the same time, some every event, as I said, every coin has basically both sides, some good, some bad. So the in a way, I mean, if there is no classes, at least in order to run the classes, in order to do with the rest of the things, I mean, online education somehow can help you. So it can basically help you in the lockdown situation like COVID-19 had, and similarly scarcity of teachers and teaching assistant. So we all know in India we are suffering from huge scarcity of the teachers in different institutions. So online education basically can bridge the gap between uh, the lack of teachers we have, so that the people can learn from anywhere, from anyone, and so on. So it also basically come up with the challenges like digital literacy. Not many people are basically very basic comfortable with the computers, because the person who has to do say uh, mm, say probably chemistry experiment, say physics experiment, so probably they may not find enough information from online classes, right? It may be probably they more familiar with the online practical that they have, I mean the practical they do in the lab and so on. Similarly, I mean, issues with the low internet bandwidth and so on, and a lot of number of issues are there, like security and privacy issue, how to basically do fair examination for students and so on. So a lot of issues are there. So how we can solve some of them, so I will discuss briefly how we are doing at the moment. So one of the, because these days when we are talking about online education, so we are assuming that everyone is good, everyone can basically attend the lecture, everyone basically can uh, join the talk, and they can basically get benefited. But as we know, no one is talking about the people who physically handicapped, or probably the people who cannot speak, who cannot listen, and so on, right? So it's kind of, I mean, we are not considering the people who are suffer, who are basically for example, the blind people, how they will learn. I mean, that's why they had a special school. So I mean, the people like us still okay, they still basically can manage by online education. But the people who cannot speak, who cannot see, who cannot listen, I mean, they are the most vulnerable person, and they cannot pursue their studies. So how we can help them, not only in study but also in daily life? So we will be basically discussing some of them, how we can basically deal with them. So advances, the some solutions are advances in digital recording technology can help. Similarly, we can use adaptive digital streaming. So one, because right now we are having Google Meet, right? The same video quality or same video recording that we are having will be delivered to everyone. But how about the person who is probably in the some rural area, some people who is in Delhi and so on? Not both person have the same internet bandwidth. So ideally what should happen, I mean there should be an adaptive way of showing probably the lower quality thing, lower quality video streaming as compared to the person who has good bandwidth. So that's why we need some kind of adaptive digital streaming which should basically deal. So I believe, I mean, the Google Meet is not doing currently, but there are many other platforms which are doing. Like for example, YouTube does, right? You through YouTube, basically, based on your video quality, you can get the different quality of the videos. So a number of things can be done. So ideally, one simple solution could be, so like in this case, right now I'm spending say 10 minutes out of my 1 hour 1 hour talk. I'm spending 10 minutes on this particular slide. If I'm spending 10 minutes on this particular slide, there is no point of continuously sending this particular frame again and again and again, right? Because the same thing. So we only need to send the frame or kind of visual information only when there is significant difference, like from this slide to this slide. Then only change the new frame. So we need to basically such kind of ways, basically, so that you can save the bandwidth. Because if you're sending any video, or you can say in any video, the most of the bandwidth is used by the video instead of the audio information and the text information. So I will be covering some of the examples how we can do so, in fact what we are doing at our lab, and that can basically help you to save uh, basically help any people despite they have the low internet bandwidth can be utilized. Similarly, one of the problem I mentioned in the online education is how basically you can conduct the fair examination. So using AI we can build some kind of proctoring tool. So proctor and honorlock is one of the two of the such examples, which can basically automatically look at different some person is doing examination. So we can continuously sense through the different modality that you have and determine if some person is cheating or not. So this is one of the examples. Similarly, we can also basically build some kind of scoring and feedback tools. So for example, I'm not good in English. In that case, I'm writing some sentences, I do some mistakes in the my writing and so on. If there is any system which can help me in learning, okay, so I have made this mistake and this is the correct answer, and over the time it can provide me how you can basically solve this problem, how basically you can performing over the time. I mean that will help me to improve myself. So same thing can be done for say text, for the speech, for the audio, and similarly video and so on. So as part of our lab, we are building such some automatic scoring and feedback system, which can help you in improving your writings, improving your speech, and so on. So as I said, I mean, when we are talking about digital education, we often forget about the people who are physically science challenged and probably suffering from some speaking or probably hearing impairment or looking impairment. In that case, I mean, we need to build such system for them. So as part of our solution, we are trying to build some solution for dysarthria and aphasia patients. Okay, so how we can improve the digital education through deep learning, lip reading. So lip reading, as I said, nothing but only looking at your lip movement, only looking at your lip movement and try to understand what the person is saying. So that can be understanding can be in terms of lip reading to text, lip reading to speech, lip reading for pathology, and so on. Similarly, lip reading. So I'll be going through in more details on that. So before going further and probably going into details how it is happening, I want you to realize how difficult problem it is. So can you just looking at the lip movement? Can you just looking at the lip movement and tell me what the person has said? Do you think it's an easy problem, right? So I don't know if the people can unmute themselves and speak, but still let me try. So at least those who can speak. So as part of this talk, usually I play a game kind of Kaun Banega Crorepati. So you need to tell me what the person has said based on their lip movement. So for example, very similar to KBC, I've given you 4 options, and the computer G is now going to show you a video where you need to focus on the person's lip movement and tell me what person has said. So right now you have 4 options. Anyone?
Conference.
Okay, conference. Anyone else? or everyone think it's a conference?
Conference.
Okay, wonderful.
Conference.
Okay,
Conference.
okay, wonderful. So here everyone is clear. Okay, so let me play the video in slow motion. So anyways, the answer is correct. So the person said conference. So I believe, I mean, you are basically doing great in terms of lip reading. So yeah, so the person indeed said conference, and with 65% you can see the confidence. So let me play another video, and so this time probably you can focus on the lip movement again, and just let me know, I mean, what the person has said. Any guess?
Speech.
Okay, anyone else, or speech is the correct answer? Anyone?
Desperation.
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 Desperation. Okay,
Yeah.
second option is desperation. Anyone else? Any other solution to this?
May you
Okay,
repeat it, please?
okay, so let me play the video in slow motion, so probably that will help you. Now what do you think?
Desperation. Desperation.
Sir, desperation.
Desperation. Okay, so the person basically said speech. I don't know, I mean, how it was difficult. So to me, I mean, this one is easier problem, easier thing than the previous one. Anyways, I mean, yeah, the person said speech. You can look at those videos. I can, after the talk, I can provide the slides where basically we have provided all the papers that we have, and all the papers and all the videos that we put on our YouTube channel, so you can follow that. So these two are kind of easy thing, I would say. I mean, yeah, relatively easier. So let me go for a difficult problem, right? Because these were kind of, and yeah, so since it's kind of very, say 1 crore question, so I don't give you 4 options. So I'm giving you probably so many options. So it's a kind of very difficult level thing. So focus on the lip movement, and please let me know what the person has said. Anyone?
Repeat the video.
Sure.
Is it Africa?
African, no. So let me play the video in slow motion. Probably that will
Yeah.
help you. So it seems difficult, right?
Yes.
It is very difficult to understand.
No, is it difficult?
Yeah, very difficult.
Yeah, difficult.
Is it difficult?
Yeah. Yes.
It's a difficult.
Is it difficult?
No.
Difficult, difficult is the word.
Yeah. So the word is difficult. I mean, if you look
Yeah.
at here, so the person is saying difficult,
Difficult. Yeah.
right? So yeah,
With
so
your clue, we were able to make out, sir. Otherwise, reading is very difficult.
yeah, so it is difficult. So assume, I mean, for us, I mean, like in this case, last case, we were having 4 options, but for computers, when they are looking at the lip movement, they don't have just 4 options, they have several hundreds options. And still, I mean, for human, as you can see, it's very difficult. So for computers, you may assume how difficult it is. So but anyways, I mean, fairly we were able to get a fairly very good result. So like close to 70 to 75% accuracy we are getting for telling what word person has said, only based on the lip movement. We don't hear anything, we just based on the lip movement. We are doing fairly well. So as expected, basically you can see the confidence of our model on this word is not as 85 or 60% before, but still it is able to kind of help you tell whether what word the person has said. So that was the part where we converted the lip movement to text, like whatever the word you have said, we converted to text. Okay, so which word you said. So the second part we want to focus on, I mean, how you can reconstruct the speech, I mean, the vice versa, I would say. So here, I mean, based on my lip movement, can you generate a speech? So one possibility could be, very simple possibility could be, so based on my lip movement, you will first understand what word I said, like find the text, and there is a number of text to speech system through which basically you can play the video, add the video audio. So in this way basically you can based on the lip movement you can generate the audio. But one of the drawback of such system is that firstly that will be computer generated audio. Secondly, the audio that will be generated will not be personalized. When I say the personalized, the that the audio will not be in sync with the person's lip movement, right? I mean, you are saying something and your lip movement is not matching with what you are saying, right? So that is the major issue. That's where what we have done, we replace the two stage pipeline with just one pipeline. So what we have done, you just give us the lip movement, we will directly generate the speech for that. So here in this case, I mean, you can see the person is saying excuse me. So I'm not sure whether you can hear the audio or not, but if not, I mean, just follow the YouTube link I have shared. Similarly, the person is saying thank you. So we are very surprised and very happy that the model that we have built, so just based on your lip movement we are able to generate the sound which is, you can say, humanistic in nature, and so it won't look like a robotic voice, or probably the but it will be the way I mean you speak. Because if we just fine tune the whatever the model that we are using on your data, in that case it will be very similar to the Samitabh movie, if you have seen, like where uh, I mean the sound is Amitabh Bachchan but the person is different, right? So our model is not only working for English but also for other languages, because we have removed the barrier of converting text and then to audio. So we directly convert the lip movement to the speech. So like the first lady has said "Ni hao ma," that is hello in Chinese. Now the she is saying "xie xie." So "xie xie" is kind of thank you in Chinese, and we were able to generate the sound, and which is fairly very well, you can understand what she is saying. Similarly, we have generated for Hindi. The person is saying "Haji," "Dhanyawad," and so on. We have generated different words like that. So how it can help in healthcare and probably in education as well. So as you can see in this video, there are people who are suffering from dysarthria. So despite they can say something, but their voice is not very clear. If you can basically also utilize the multimodality aspect here, so whatever the sound they are generating, but also look at the lip movement they are generating, in that case you can infer what they are saying, and it will be very very good for them. Like you can communicate with such people and they won't get frustrated, because most of such patients get frustrated and go into some mental health, because no one is speaking to them, and even I want to speak to them, I cannot understand what they're doing. So that's why we need some kind of AI tool, or you can say some kind of tool which can help us to communicate with them efficiently. So this is what we are doing for dysarthria. And how it works, another work basically what we have done. So as I was talking about internet bandwidth, right? So if right now I'm communicating with you, I mean there is no need to send all the frames. If there is a major changes are there, then only. But what about there is not slideshow, I mean I'm just communicating, in that case if you look at I'm speaking, then only my lip movement is mostly changing, right? The rest of the part is almost same. So how about just give me a picture of mine, right? Just give me a picture of mine and give me the whole audio conversation. So what I will do, I will generate the whole video for you, whole conversation. So it's kind of I will generate the lip movement. So whenever I'm saying something, the corresponding lip movement is generated and so on. So in this way, the input is one just image of the speaker and then audio recording of the phrase or whatever the thing the person want to say. And using our model, we can generate the rest of the lip movement and generate the video for that. So for example, and how it works basically, so the concept behind is called GANs, generative adversarial network. So it basically generate the frames. So for example, you have just given me this input, but I generated the rest of the frame for the corresponding phonemes you have, because as you know, the audio is nothing but a different smaller element is called phonemes. So this goodbye is made of the different phonemes like goodbye, right? So if you know the basically here we try to map the phoneme to viseme. So viseme, the way phonemes are the smaller element of audio. For a video or lip movement, the visemes are their corresponding elements. So in this way, if you just give me the first frame, I can generate the visemes, I mean the intervisemes for different phonemes you have. So in this way, I mean, we have generated the video for goodbye, just given speaker image, first image, and the whole audio. We can generate the rest of the things. So same we have done for English as well as we have done for other languages. So for example, as you can see here, so this is the video we have generated. So we have generated the rest of the frames, and only the first frame is given. Same we have done for Hindi. Similarly, aap kaise hain, aap kaise hain is basically made of the different phonemes like these, and these phonemes are fixed for different languages. So once you have the phonemes, you can generate the, I mean, and there is a set of visemes for different languages are also fixed. So if you just concatenate this available visemes, it, the video will not be smooth, because you will see, I mean, there is a kind of short change at different phonemes that you have. So that's why we need to generate a number of intervisemes in between. So these intervisemes we have generated using GANs. So in
So
this,
there is a question. I think it is an interesting one. That's why
sure,
I interested
sure, sure,
you
sure,
about that.
sure.
The question goes like this: for a particular language, say Hindi, do we need to train the model on the set of words that are supported by the language so that the lip sync can then be tested over these words?
So the thing is, I mean, yeah, so di different word, different phrases are made of, again, so made of different phonemes. So the idea is, I mean, even though the same word has not been seen by machine learning, so that is the beauty of machine learning, right? Otherwise it will be very similar to the rule-based system. So here, I mean, you may not need to have the exact word in your training set, because the word is made of different phonemes. So if you have seen the all possible phonemes available in the language through different words or different sentences that you are reading, then also, I mean, it will help you to somehow understand the new word. So again, ideally it will be great if you can also have that word in your training set, so that whenever some other person, not the same person, because if the same person is saying, you can easily interpret, even the other person is saying the same thing. Because if I have to say aap kaise hain, so either I say aap kaise hain or probably you say aap kaise hain, I mean, the visemes, or you can say the phonemes, will be the same, right? Phonemes will be the same, even the lip movement will be similar. I would not say same, but similar. So that's how, if we can see, if we can basically provide a good number of examples to our model while training, it can and hopefully should deal with new data, new word made of all those phonemes. Did this answer your question?
Yeah, it's
Okay.
there is another question: is what deep learning technique is used for disease prediction in crops? Like the system has to process various images to predict the diseases in the crops.
Okay, so that's altogether a different thing. Yeah, but anyways, I mean, uh, usually when we say you have the crops, right? So you have the crops, you are, because even during my PhD, what we have done, what we have done basically, we captured the sound, because I was working with IT Bombay during that time. So what we have done, we have basically installed different sensors, and these sensors basically continuously captured the sound which is generating happening in that case, basically you can say the field. So based on that sound, we classify which insect it might be. So once you know which insect is there, you can also help, it can also basically help you to find out which disease it could be with the crops. So that is one possibility. Second possibility could be, I mean, as I said, I mean, here only one modality will not help you. If you know, I mean, this is particular this temperature, and at this temperature this particular type of most disease are most popular, so this could be another accuse to that. And thirdly, the image processing, the things you're saying, yeah, so of course you need, if you can provide us, if probably to the model, the different pictures of the I mean different crops that you have, right? And based on that, I mean, because it's more like it will be a supervised thing, you need to first a good amount of examples. Okay, so if leaves, or probably the pictures of the leaves, or probably the your corp is like that, in that case, say this is healthy one, but this is say having some disease. So in that case, you need to train your model accordingly. But yeah, multiple modalities, be it in form of audio, video, audio, and probably other sensor information like temperature and so on, will help you in
There is
solving.
another question, sir, that which says that, I mean, the idea here is when we save word or when you are generating the video for say, then in that case, if it is whispering or a routine talking, or if it is crying, the live movement should be different. So how to deal with that?
Yeah, it's a very good question. In fact, yeah, it's a very good question. The thing is, uh, AI or machine learning is not can solve everything. As I said, I mean, AI and machine learning has a lot of limitation, and rule of thumb is like that. Deep learning or machine learning is like what kind of example it has seen, it will work only in those cases. If you whisper, I mean, probably deep learning model, our model won't work, right? So yeah, so if you want your model to deal with such kind of thing, in that case, I mean, you also need to feed example for those whispering, so that it can learn while whispering, if this for this type of leap moment, this word could be there. Yeah, but it's a very good question. Even, I mean, there are a number of issues like two words might be sound similar, but might be the uh, might be the different, like been, seen. So lip movement for both are different. I mean, the same, been, seen, right? But the words are different. So in that case, I mean, yeah, again, it's a difficult thing for machine learning models to learn. So that's how to solve it. I mean, you can use some language model, you can use probably other modalities, information which are there, and so on.
So, sir, some new questions are coming in, and I also have some questions, but I think
Sure.
first you complete your part, then we will have a reserved session only for question answer, maybe at 1:15 around.
Okay, sure. So, okay, then what I will do, I will try to finish my slide in next 15 minutes so that we can have 15 minutes for the question answer. Is this fine? Okay, I hope yes. So this is the same thing. आप कैसे हैं? We have generated the lip movement for आप कैसे हैं, and to our model, and these kind of things are very useful in scenarios where you don't have data available, because as I said, for machine learning or deep learning thing, I mean, you need a lot of data. So how about the data is not available? How you basically train your model? So in that case, if we have such kind of system which can basically generate the new data without seeing anything, we call it zero shot learning, right? So in that case, I mean, you can synthetically create the data and use that for model, and once you have model, you can just have a use in the real life. So this is one of the thing. Second thing I want to highlight, like improving digital education through touchless typing. So can you think without touching anything, without touching the keyboard, can you type anything? Can you think about this? So we have recently published a paper. So what we have done, only looking at your head movement, I mean, suppose keyboard is in front of you, only looking at your head movement, we type the word that you want to type. So like in this case, we have divided the keyboard into different clusters. So what you have to do, simply look at the different clusters for the word you're typing. Suppose you want to type love. In that case, just look for this cluster having L, this cluster having O, this cluster having V, and this cluster having E. So in this case, I mean, you basically we do the cluster prediction sequence. So we predicted, okay, so the person head movement is basically looking at 6371. So these are cluster number 6371. So for this cluster sequence, these could be the possible words. In this case, basically you can show the possible words, and you can further improve using some other modalities, as I said, and you can select the word. So in a way, without typing anything, you can type the word. So ideally, I mean, we want to, if you look at this lady, so she has also wear some you can say the kind of headgear here. So that is called muse. So that muse basically also capture basically the brain movement, brain signals. So here I mean, we are aiming, again, it's a very difficult problem. So here basically we aim to just capture the brain signals, and with that brain signal, just type what you're thinking. I mean, so this is the ultimately we are willing to do. So right now, I mean, that is very difficult to solve. So that's why we have combined with the head movement. So just look at the head movement, just look at, and by the way, there is a number of work. a few works which capture these brain signals and tell you what you're thinking. Suppose you're thinking about a cat, then basically just capturing your brain signal, it will tell you, okay, you're thinking about cat. So there are some work which are exist. So that has motivated us to basically look into this direction. How about since this particular headset is not, because not having so many electrodes and so on, so the brain signal captured are very very weak, I would say. Because you might have seen people who are wearing a number of good amount of electrodes in their head in that case, so that you can capture more signals and probably build a better model. But again, the problem is that, I mean, that is not realistic. You cannot wear such a huge uh, uh, thing at your head and just go around and live together. So another thing what we are doing, we are building a grammar error correction system. As I said, I mean, such system can help you with dealing with a less number of teachers that you have, so that the student basically can write some sentence and get the feedback. So you can say Grammarly is already there. So how about something for Hindi? So have you come across any grammar error correction for Hindi, or say Urdu, or whatever other languages? So that has motivated us basically build grammar error correction for Hindi. So right now we are building grammar error correction for Hindi. So if you give us any incorrect grammar sentence in Hindi, we will correct and provide the feedback where you have done mistake and so on. Similarly, we have built for English as well, and we are working with an NGO in called iSaksham. One of my senior, Aditya Tyagi, is leading this. So that NGO is basically working for the Naxal affected area, and we are basically helping them with how we can improve learning using AI. So in this way, basically, we are the students write some incorrect sentence, we provide a correct sentence, we also provide what mistakes they have made, what correction are there, and we track their record over the time, so that we can generate a kind of report to them how you're improving over time. So we are recently going to start with Delhi government as well regarding this project. So the next thing is about automatic scoring of essay scoring system. So this is very similar to the grammatic correction. Here basically we aiming to basically uh, how about you can write an essay and get the feedback whether you're doing correct or not. So it's not only useful in feedback or self-learning, but it can also deployed for say, suppose you want to hold a competition, the effect of COVID-19, and say the prize money is 1 lakh rupee. So if the prize money is 1 lakh rupee, in that case, say 1 lakh people has participated. It's not possible for you to manually look at all 1 lakh entries and shortlist some of them, right? It's not feasible for you at all. So that's why we need some kind of automatic system that can basically look at the essays and grade them and so on. So this is exactly what we have done. So we have built a system and published this work last year. So what it does, we look for different criteria, like for a given question, say like effect of COVID-19, you write something. So here there are two candidates who is writing something. So I mean the question is different here, just but take it as an example. So here the person is just writing anything, even there is a, say, the and there is a spelling mistakes, there are no context, you not making this paragraph not making any sense. So that's why you, based on the different criteria, you can provide the recommendation feedback, like the context is low, say the word use is okay, just not very good, and probably the logical formulation is low, temporal information is low, and so on. But the some other person who has written very well, everything is in place, I mean you can provide the, okay, so everything is high, 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 and so on. So based on that, I mean you can compute the score. So this person has been given a recommendation score of 2, and this person is given recommendation score of 0. So in this way, basically you can use this such kind of system not only for self-learning, but also for huge evaluation schemes and so on. So same system we have built for a speech scoring system. For a given speech, basically what we are doing, just consider the example of TOEFL. In case of TOEFL, for a given question, you speak something, say something. So right now at TOEFL, the ETS basically look at, assign those recordings to some person, human, and they listen those manually and give you a score. Right? I mean that's why probably ETS, TOEFL, and probably GRE, they cost you a lot of money, because that involves you human and so on, right? So how about basically we can build a system which can do that automatically. And so for example, right now, I mean the same system, same basically recording is go to say two people, because you cannot just rely on one person. So how about I replace one person with the AI system? If there is any disagreement between the AI system and the human, then only it goes to the second person. So if say if the 90% of the situation there is a agreement and only 10% of the cases where there is disagreement, it means you have saved 90% money of one human power, and that is huge, especially when you are dealing with a huge number of test takers and so on. So that's how we are doing. In fact, we are already working with a company, kind of competitor of ETS TOEFL, and we are building very similar thing for them. So another thing what we can do, I mean, I just quickly go through this. So what we have done, how about we can help the student by learning the time complexity of a given code. Can you think of this? Because right now, I mean, if I write, I given you basically a piece of code and ask you what is the time complexity for this, right? For beginners, it might be difficult to know what is that. So in that case, I mean, you need some ways to basically learn. So in this way, basically what we have done, we have built a machine learning model, and we have considered these 5 classes, and with the accuracy of 70, 80, 70%, 71%, we are able to tell correctly, okay, so which class is that for a given piece of code. So basically, we can basically further improve on and take this accuracy to even higher level, so that students basically can rely on the output of this and confirm what they are thinking is correct or not. Similarly, we are building some tools as well. So like test management tool in this case, because the often for data collection or for evaluation, people think of just capturing the questions through the Google form, but Google form only support the text based thing. So what we have done, we have built audio and video support as well. The question input as well as the responses can be in our audio and video as well. Similarly, we have built an Arduino tool where you can and we have also basically open source this. You can segment the different audio into small parts and do the annotations. Similarly, we have built a kind of course management tool. So as you can see here, so you can see here, this basically is the process of student across different courses. So based on the person's performance, we can recommend new courses to him or her. Similarly, what are the different courses it has, how the person is performing over the semester, and how much courses has been completed. So it basically helping building a kind of ERP for the students. We have also integrated the timetable and so on. Similarly, I mean, we have built a kind of tool to which is basically both of such system we are going to use at IIIT Delhi. So because we have limited resources, limited facilities, so and we can provide only on say sharing basis. So how about we book them? So that's why for say sports block, for different sports activities, for lecture hall, for other resources that we have built a kind of booking tool where you can book different items for given time slot and so on. So finally, how AI can taught at undergrad secondary level. The reason being I'm covering this because when the physics started, physics was limited to only for higher studies, like only say masters and the PhD student were studying physics. But that's why only very few people were studying physics. So the people have thought, I mean, there is a huge project which were discussing how we can promote physics at more people. So that's how what they have done. They have simplified the physics and push it to so school level, so that no, by removing the complexity and just showing the its application and the benefit of physics, so that the people get more interest and jump into the studies. So that's why we need to do something similar to promote AI. So like building some drag and drop tools, data sets, so that they can try building some fun application like lip reading that we have tried and so on. So finally, that one of my recent works. It will take probably just 2 minutes and more, so that we can go for the question answer. So deep learning for finance. So how about, so it's not for education, but yeah, the reason being I added this slide because I was giving a talk at management school. So I thought, I mean, it's good for them. So what we have done, so can you think of predicting the stock price, or probably predicting whether which stock is going to uh, improve over time, or probably which stock having a lot of risk and so on, using deep learning. So this is what we have done, and we have published to a very top conference, a very popular conference recently. So what we have done, so here you have historical data of the stock. You have So what we have proposed, so every companies basically have a earning calls. So earning call is basically a CEO meeting with the stakeholders every quarterly and so on, and do a kind of discussion and deliver talk how the stock is going well, not what are the plans and so on. So based on those recordings, based on the historical financial metrics, we have basically built a deep learning model which can help you to learn whether the stock price is going up or down, similarly whether it's a volatile or not. So in this case, if it is less volatile and probably the price is going up, it means, I mean, the stock could be a good thing to buy. So in this way basically you can buy such stock, and we have basically used the machine learning deep learning models for that. So this is a very similar work that we have done. So here basically because when we are dealing with the audio recording, we are looking at the different speed audio features, like whether the person is confident or not. Because if a CEO, while addressing its stakeholders, is not confident, probably he look like very dull, or probably something is happening in his mind and so on. So it means confidence could be a good metric to understand whether it's going well or not. Same for hesitation, same for variation and fluctuation. So the different features which captures these thing, and we have used that and predicted and got the very good results. And finally, we have also added the graph to it. I mean, how we can basically add the graph information to this stock to improve the result further. So as you know, I mean, there are different stocks which are related. So if we can connect them, probably we can get better results. So for example, if Adobe is doing well, most likely probably other things may also perform very similar. So for example, you can see here in COVID situation, I mean, the computer technology company like Adobe, Synopsys and Autodesk, they are doing very, very similarly. Same for the transportation. As you know, I mean, the transportation uh, the transportation business has gone down significantly due to COVID. So as you can see, over the March, April, the transportation has gone very, very low, and that's how they are performing very bad. And all such companies, all those travel companies are performing very equally, very similar. And similarly, the healthcare companies, due to COVID, they are keep booming. Their business keep booming after the COVID situation, right? So, and that's how, I mean, you can see, I mean, the graph information can further help us in dealing with any such kind of things. So very similar technique we have also used in our suicidal ideation paper that we have recently published. So in conclusion, we are trying to help society through our AI solutions in different ways, by in education like scoring essays, speeches, grammar correction and so on. Similarly, building AI assisted tool to help digital education, stock movement prediction, and so on. So this is a number of work we are doing currently. And specifically, I usually add some of those links which will be helpful for probably some students are also attending this talk, and for people who want to explore machine learning, deep learning. So this could be these blogs are very, very useful, written by my student. So like starting with machine learning and deep learning, starting with natural language processing and so on. So this will basically help you provide at least a good starting point where you can further explore and familiarize yourself with these domains. And thank you so much. I hope I'm within time, and I'm open for your questions.
Thank you, sir, very much. There are, in fact, a lot of questions, so I will start one by one.
Yeah, sure.
One question by Ms. Andalib is, for detecting two separate words, there should be some break between the two. And if in a speech there is no break between two words, do we get the possibility of wrongly recognizing the word?
That's true. That's true. I mean, but usually whenever we are saying anything, always between two words, I mean, there is a little pause, I would say. Just like hi, like interested in working with us. I mean, and again, it's a very, very difficult problem, I would say, because this is, I mean, ASR problem is currently dealing with, because when we are saying anything, even, I mean, not only word, but also the sentence, when sentence is ended, because once you are able to know when sentencing, you can perform a lot of other NLP task on that. So yeah, it is very much true. I mean, often it is not that easy, but thanks to deep learning, it has basically beam search and so on. So because when we are saying anything, I mean, it is not treat my audio as a word. It treat as a different characters, so it keep giving characters for different audio signal it is receiving, and it's keep doing beam search over it. And once it has probably enough number of words, enough number of characters, and it try to find some mapping with the word, it try to predict, okay, this could be the word. So I mean, yeah, so a lot of thing is happening over there to find when the word end and probably other words start and so on.
Okay, so the next question is by Mr. Muhammad Akib. He's saying, sir, I cannot understand why we use GANs, generative adversarial networks. How discriminator will find that some image is real or fake? Sir, voice is
Sorry. So yeah, so these days, I mean, I agree with the question. I mean, why people need GANs? As I said, I mean, there are both side of any coins, right? So here, I mean, the people are also using GANs for, say, deep fake, where they are generating the fake videos. And there are GANs which can help you with many other stuff. For example, we are working with Delhi police, or in fact any police system you can think of, right? So how about you just tell me the facial attributes? Some suspect is look like that. One possibility, you tell those attributes and the sketch artist is there and he will generate the sketch, right? Firstly, I mean, it involves a lot of time and that may not be that accurate as well, right? How about using GANs, I just generate the face based on the facial expression that you're telling me, facial attribute they're telling me. So that is the thing. And regarding the um question about discriminating between fake and real for the discriminator, I mean, while training we know which is fake and which is real, and it try to, I mean, there are discriminator and um, generator, right? The generator try to generate and discriminator try to fool and so on, right? I mean, that is
and
part of the training.
okay, so, there are some general comments in between,
Sure.
but I will just pick the questions first.
Sure.
And the next question is, can you give some details on algorithmic complexity analysis? I think Rachna is referring to that prediction thing of code and identifying the corresponding class of the complexity. Yeah, I think this is the one she's talking about.
Right. So here in this case, I mean, we having 5 classes. So we have dealt with this as a classification task. So you have basically, I mean, there is a website. Basically, we have collected the source code. I mean, for different submission. So in this way, for order n, we have 385 such codes for different problems. Similarly, order n square, we have 200 codes for different problems. So the idea is, because as I said, in deep learning or machine learning, the idea is, so here in anyways, I mean, the best result we got from normal machine learning, not with the deep learning, right? So here the idea is, I mean, you need to show as much as example to the computer so that it will learn. So here it is, right? So that's why we have considered 5 such classes, collected a good number of examples for them, whichever we could collect. We have asked 2 people to manually annotate that. I mean, both students were basically working with Adobe at the moment, so at least we can assume that, I mean, yeah, so whatever the annotation they are doing is correct. And we have also compute inter annotation agreement and other stuff, so that we know, I mean, if some samples is incorrectly annotated, we can discard them and so on.
Next question is, if some non-native speaker speaks a language, like some English speaking person, he or she is speaking Hindi, can we generate voice from his or her lip movement? And if yes, then how?
Yeah, it is. I mean, if you look at our example, we have generated English word. I mean, language is different. I mean, we have also generated the language, by the way. I mean, we have generated the English word for the Indian speaker, just like the person is saying, "How are you?" I mean, even the example I've shown, because the data set that we have used is not Indian data set. So the data set that we have used is one of the publicly available data set called OLU-VS2. So it has 52 speakers across the world, and I am not sure, I mean, more than one speakers in Indian. So it's kind of, most of the speakers are foreigners, right? So it has trained the model on that particular data set and kind of tested on probably the data set that we're doing. So of course we need to do fine tuning often cases, and it is difficult as well. So Yeah,
Okay, sir, before moving forward, I have also one question.
sure,
Uh,
sure.
the question here is, sir, that in when we talk about multimodality, it means sometimes we like this. Some examples we have already seen. We are taking the audio in, we are taking the video in. Sometimes we are taking also the image in, and they are represented by different feature vectors. Their size is different. Their feature values are different. So how to put all these things together to reach out to some decision?
I mean, there are several ways. I mean, one simple thing people try is like simple concatenation. It's kind of early fusion. So in that case, I mean, the feature, because I agree with you, it's a very difficult problem because the different feature has different feature space. You cannot just simply join them, right? So that's why, I mean, the people basically do the fusion at different level. One possibility is kind of early fusion where basically they concatenate the different features and pass it to model. Some people do the late fusion. In that case, basically what do they use the different models for different modalities, and whatever the outcome they are getting, they combine the outcome, right? There are other ways as well. Basically they try to map on the same space and then basically pass it to the model. So I mean, there are a number of work on the multimodality which can help you, but just to simple answer, yeah, so there are several ways of fusion. One is simplest way is the early fusion, another way is the late fusion, and there are hybrid fusion as well, sample specific fusion. A number of fusion techniques are there.
Okay, thank you, sir. Next question is, what's your opinion on deep learning models? Do we not yet know whether it is really understanding the task?
So the deep learning model is the one drawback of deep learning model is that they are kind of, you can say, the black box. You don't know exactly what is happening inside, because with the traditional machine learning model, you know, I mean, which feature you are giving, so you know which feature has which effect. In case of deep learning, I mean, it's like a black box. That's why, I mean, right now a lot of focus has been on how we can add the explainability, how we can add basically the explainability to the models. Like if I'm saying this person is should be given say for example, if this particular image is cat, I don't need to just say it's a cat, but we also need to add the explanation why it is cat. So that's why a lot of focus currently on the explainability of that thing. So deep learning is, it's more like a, it's more like at least we know giving good results at least on different problem, we all know. That's why deep learning is getting very popular these days. So that's why now everybody knows deep learning is working, they don't know why it is working. So that's how, I mean, currently people working on very uh, focused way at the moment.
Okay. So next question is, have you implemented fuzzy logics in any one of the models that you have explained? Is fuzzy logic good to include in the models we build in future?
Fuzzy Lassi is definitely good. I mean, in some of one of my work previously, I mean, probably 2 years before. So, because right now, as I said, I mean, we are working on suicidal ideation problem for last 2.5 years. In one of our earlier work, we have used fuzzy logic to solve the suicidal ideation problem, and it has gave some good result, I would say. But later on, I mean, using the deep learning model, we have beaten that score very significantly. So kind of, I mean, kind of deep learning model is again outperforming the, at least the problem I have worked on for the fuzzy system.
Okay, so sir, this is it. No more questions yet. Last question from my side, sir.
Sure.
What tools do you use to train models and test models? Do we use some already built models, or do you write the code from the scratch?
I mean, we believe if some code is available, we should use it. We need to verify it. But in terms of framework, we use, I mean, Keras, we use TensorFlow. I mean, these are the framework that we use. And whatever the libraries are already available, you do, because many times, I mean, you do not need to write everything from scratch. If some part is available, you should use it so that you can focus on the rest of the part and build your system.
Okay, thank you, sir. Thank you very much. It was a really nice session, and participants have also applauded your effort and how you explained the thing. The best thing about today's session is it has something to do with the social life, social good, and this is first kind of session that we have on social good on this whole FDP. And you, I mean, explained everything really well. You keep it simple. That is also one of the a very important and difficult task to do, especially in the case of machine learning and deep learning. Often sessions become too technical, but very thank you, sir, for this informative session. It was a really nice session. You are doing excellent job, excellent work you are doing. So and thank you for giving us time from your busy schedule for coming out, taking some time out for our FDP at Department of Computer Science, AMU Legal. Definitely, we will collaborate with you again sometime soon. So thank you once again, sir. It was really nice having you with us on this FDP.
Yeah, thank you so much, Nadeem, and thank you, Sajid, and thanks all organization committee. It is indeed, my pleasure basically interact with you all, and I was very surprised to know. I mean, the first lip reading question that I asked, and everyone has answered correctly. That is the best part. Yeah. Anyways, I mean, thank you so much, everyone, and it is my pleasure, and I will be very happy to help you out. Probably collaborate in the future whenever required. Thank you so much.
Thank you, sir. All the participants can leave now, and next session will start at 2:30 p.m. Thank you, sir, once again.
So regarding slides, I can share the slides with Nadeem and Sajid. You can get with them. Thank you so much.
Okay, thank you, sir. Thank you.
Okay, bye.